your book anywhere. So the position or the x-coordinate of a particle moving on a line is given by x of t equals negative t cubed plus 7t squared minus 14t plus 5, where t is greater than or equal to 0. And it is in seconds, and x is in meters. Sometimes I told you that x, because the position is moving back and forth horizontally, that's why it's x of t, but that is its position. The question is, find the instantaneous velocity at any time t. What should I do? Find the derivative of the position. So I'm going to write x prime of t equals v of t, and what would it be? Negative 3t squared plus 14t minus 14. You're going to bring snacks when I'm not here? Sure.
Why were you choosing to miss a Friday when you
I know.
snack day?
Jeez. Shouldn't be missing snack day. You can, as long as you bring some to share with Mr. DeMarco. Okay, how would I find the acceleration? How would I find the acceleration? So it's the derivative of the velocity equals the acceleration. And so what would that be?
9t.
Negative 6t plus 14. When is the particle at rest? What are we trying to find? When is the velocity 0? So I'm going to write v of t equals 0. So that is the equation, negative 3t squared plus 14t minus 14 equals 0. Now here's the deal. If it is whole numbers, then we can factor it. But if it's not whole numbers, then, or integers, or, rational numbers, sorry. But if it's not, if it's approximates, we'd have to use what to solve that? Quadratic formula. So I'm going to think here. Factors of 14 are most likely 7 and 2. I don't think it's factorable, but let's do quad formula. So t equals negative b, so negative 14 plus or minus square root 14 squared minus 4 times negative 3 times negative 14 all over 2 times negative 3. Let's get our calculators out and do what's underneath the square root. And I get approximately 5.291. You can truncate or round. So I would do negative 14 minus that, or plus that answer, divided by negative 6. So for one of them, I get approximately 1.451 seconds. What's that? Nope. Did you add the whole thing? Did you type in what I typed in? And then you typed in, I did the square root.
Oh, I got that.
Okay. And so then we're also going to do negative 14 minus 5.292 divided by negative 6. Okay. So there looks like there would be 2 times when the particle is at rest. And that means just for a second, not even a second. So that would also mean that's where the particle could change directions, if we could find where it switched from positive to negative, possibly. Okay. So here's what we're going to do. Let's just make, and we're going to spend more time with these sign charts. Let's kind of summarize what's going on with V of t, okay? We know that it starts at 0 because we're told that, at time equals 0. We know that it hits 0 at approximately 1.451. And then also again at 3.215. If we could just figure out, not even calculate, whether the velocity is positive or negative, we're going to be able to figure out when the particle is moving to the right and to the left. Because when the velocity of the particle is positive, it would be moving to the right. And then if it would switch to negative, then it would be moving to the left. So let's pick a number that's easy to calculate, that's in between 0 and 1.451. How about 1? If I plugged in 1, and did negative 3 times 1 squared plus 14 times 1, let's see, negative 3, that would be 11. 11 minus 14 would be a negative number, correct? Okay, so what it sounds like is that the velocity is negative in between here. How about let's plug in 2? Are you okay with that? If I did negative 3 times 2 squared, let's see, I might have to do some work here. 14 times 2, all right. This would be negative 12 plus 28. Let's see, that's 16, right? 16 minus 14 is positive. All right. What this helps us do then is it helps us summarize and be able to describe the motion of the particle. Okay? So, this is what I'm going to write. The particle moves to the right. We did. For D, not to the right, to the left. Okay, so the particle starts out moving to the left because its velocity is negative. So I'm going to say for the first 1.451 seconds. Since V of t is less than 0, you need to justify. A sign chart doesn't justify, you have to state that. A sign chart is what you use to justify. Then it switches direction and moves to the right. Until 3.215 seconds. Since V of t is greater than 0.
If you took the AP test, do you think you'd get like 100%?
No.
Like 98%? Would she get a 5?
Yeah.
Oh, she'd get a 5 for sure.
There's sometimes when they release things, like I have to look. They release the free response like 5 days after you take it. And there's sometimes parts of the free response that I'm not sure on.
So
but if I go back later and look at the answer, then they make sense to me, but I don't know if I would.
Like if it were just like a normal test, you would literally get like a 95%.
I hope so.
I believe in you.
Okay, hey. Staff student. All right, so, hey, I forgot. What do you think happens after 3.215 seconds? Probably goes negative again, because it stopped, but I mean, if we did that, like at 4, let's see, if we did negative 3 times 16 would be like negative 48. Yeah, I see it's negative again. Okay. So we have addressed there when the particle changes direction. Are y'all done writing? Okay. So I had you skip this because we did it actually the other day as an opener. And skip this, and then we're gonna just do one small application. I hope it makes sense in economics. Yep, you did that already as an opener the other day. Okay, economists. Did I pronounce it? Economists.
Oh.
Have a specialized vocabulary for rates of change in derivatives. They call them marginal. In manufacturing operation, the cost of production is a function of X of the number of units produced. The marginal cost of production is the rate of change of cost. So it's basically dC dx, which in common terms, that's the derivative. Okay? Sometimes the marginal cost of production is loosely defined to be the extra cost of producing one more unit. And so it's basically maybe helping somebody figure out, is it worth it to produce the more units, because it's going to give them like a per unit increased cost. So there's not much here. It's really just understanding what this word marginal cost means. Marginal cost is dC dx. So if this was the cost equation, 2,000 plus 100x minus 0.1x squared, we're going to find the marginal cost of producing 100 washing machines. So dC dx, or C prime of x, and then we're going to find it for 100. Okay? So here we go. What would happen to the 2,000? And we cancel. This is 100. Then this would be minus 0.2x. We plug in 100 washing machines. And what do we get? Well, what's 0.2 times 100? 20. 100 minus 20. 100 minus 20 is 80. So $80. Okay, and then if we go back and look, it says it's extra cost of producing one more, loosely. Okay. So really what they're basically it's going to cost them $80 more for producing those 100 extra washing machines.